Next, I have Robertson's method. So I will continue with our previous number, which is minus 5 and minus 7. I will write them here, as we can see. So the first step with Robertson's method is to ignore the last bit or the last number of the second number. In our case, which is minus 7, so I will ignore the last number, which is 1, and I will perform a normal multiplication. Here I have 1 multiplied with the first number, so I will just so 1 multiplied with 1, 1, 1, 1, and 0 and 1 and 0. So I will do a shift here and I will multiply the 0 with the first number, so 0 0 0 0 0 and 0. Also I got a 0, so I'll do a shift to the left, 0 0 0 and 0. As we finished the first step. So, and the second step is, here we can notice there is a gap for two numbers, and here we have a gap for one number, so I'll fill it with the same number of the last number. Now in my case here I have 1 here, so I'll fill it with 1, and for this gap I have 0 here, so I'll fill it with 0. And I will do addition. So here 1 plus 0 is 1, 0 plus 0 plus 0 is 0, 1 plus 0 0 will be 1. Here I have 1 and 1. Okay, and I got a 6-bit number. I will extend it to 7 bits number, because here I started with 3-bit multiplied with 4, so I have to get a 7. 3 bits multiply with 4 bits, so I need to get 7 bits, and here I have just 6, so I will extend it by repeating the last number, or the most significant bit. In my case here I have 1, so I will write another 1 here, and I started with 3 bits. I will add 3 zeros here. This is our fourth step. First we extended the result, and because I start with 3 bits here, so I will add 3 zeros here, and I will do our last step. The number that I ignore, I will multiply it with the first number. In my case here, I ignored the 1, so I'll multiply the 1 with the first number. 1 multiply with 1, I will get a 1. 1 multiply with 1, I'll get a 1. 1 multiply with 0, I will get a 0. And 1 multiply with 1, I will get a 1. And the last thing is, I will perform a subtraction. This is the last step. So here 1 minus 0 will be 1. 1 minus 0 will be 1. Here 0. 1 minus 1 will be 0. 1 minus 1 will be 0. 1 minus 0 will be 1. And 1 minus 1 will be 0. And here is our result. So first of all, we ignore the first, the most significant bit of the second number, and we ignore it, and we multiplied it with the first number, and we get this result. After that, because of the shifting, gaps appear, and we filled it with the same number of the last of the most significant bit, or the last number of this number. In my case here I have 1, so I added 1. In my case here it was 0, so I will fill this gap with 0. For example, if this was 1, so I fill it with 1. Okay, but this is not our case here. And I will perform an addition. I performed an addition here, and after I perform the addition, we got a 6-bit number, but we need a 7-bit. Why? Because we started with 3 bits and we multiplied it with 4. So 3 plus 4, we got 7. Plus 4, we got 7. So I need 7 bits, and this will be easy by just extend the 6-bit number to 7-bit number by repeating the most significant bit. So here we have 1, so I will add 1 here. And the last step is multiplying the number that we ignored at first, which is the 1, with the first number. We multiplied it, but first I started with 3 bits, so I will add 3 0 here. 1, 2, 3. If I started with 4, I will add 4 zeros, but this is not our case. So after that, I will multiply the number that I ignored first with the first number here. So 1 multiply with 1, I will just multiply it and write it here. After that, I will perform a subtraction.